Hi everyone, my name is Mubashir Shamim from CS Department of Shri Venkateshwara College of Engineering. Today we want to discuss about an improved transport layer protocol for wireless sensor and networks. Abstraction. Wireless sensor networks are a kind of communication networks having independent sensor nodes that perform multiple hoop and hawk network to transfer data. In the past few years, various transport control protocols in wireless sensor networks have been developed and proposed in the literature. In this paper, we have analyzed pump slowly, fetch quickly protocol and presented an improved transport layer protocol for wireless sensor networks. The improved protocol has been analyzed based on various factors such as average latency and average error tolerance, and it is found that proposed protocol is better than PSFQ in terms of these factors. Introduction. Wireless sensor network is a self-organized distributed system consisting of one or more base stations, which are usually called sinks, and perhaps tens or thousands of sensor nodes sprinkled in a physical area. Integration of the information sensor through sensors, computations on that, and wireless communication make the sensor node able to gather physical data, process that data to obtain crude information, and reports to sinks. The sink can query the sensor nodes for more information. WNS have several characteristic features. The major focus in this paper is on the design of transport layer protocol for WSNs. Transport layer protocols are used to mitigate congestions and reduce packets loss to provide fairness in bandwidth allocation and to guarantee end-to-end reliability. However, UDP and TCP protocols which are currently used for the internet cannot be directly implemented for WSNs. For example, UDP does not reliable that is often needed for many sensor applications, nor does congestion control that can lead to packet loss and unnecessary data. Related work for WSNs, various transport layer protocols have been designed to address various issues such as congestion control, reliability, or both. A brief summary of the related protocols is provided in this section. STCP Sensor Transmission Control Protocol is a generic end-to-end upstream transport protocol. It provides both the congestion control and reliability by allocating most of the responsibility at the sink. It provides controlled variable reliability utilizing the diversity in applications. Garuda is a reliable downstream data delivery transport protocol for WSNs. It addresses the problem of reliable data transfer from the sink to the sensors. Its design is a loss recovery core infrastructure and a two-stage NAC-based recovery process. RTMCs, reliable transport with memory consideration, is inspired from the flow method and provide hop by hop retransmission to make sure all of the sinks be received by the sink with 100% reliability. Analysis of PSFQ protocol. PSFQ is a hop by hop downstream transport protocol which is reliable, scalable, and robust. It uses NAC based loss detection and notification and local retransmission for loss recovery and is basically designed for retasking reprogramming applications which require 100% packet reliability in downstream direction. It consists of three operations: pump, fetch, and report operation. The pump operation controls the rate at which data packets are passed into the network. The fetch operation requests a retransmission of the lost packets from the neighboring nodes. Lastly, the report operation provides a feedback status to the user. This way, it provides 100% packet reliability. Message transmission. The pump operation controls the injection of packets into the network. This operation is important in controlling the timely distribution of code segments to all the sensor nodes and providing basic flow control so that the reprogramming operation does not abstract the regular operation of the sensor network. For doing so, proper scheduling is required for data forwarding. PSFQ adopts a simple scheduling scheme. which uses two timers Tmax and Tmin. The important task of PSFQ is to recover the lost packets very quickly among the immediate neighboring nodes within a controllable time frame. For that, there is a need to provide a timer buffer. Tmim gives an opportunity to a node to recover any missing segment before the next segment comes from its upstream neighbor, since a node must wait at least before forwarding a packet as a part of the pump operation. Local loss recovery. Sensor node starts PSFQ fetch operation to do local loss recovery. It is started when a sequence number gap in a file fragment is detected. Channel impairments such as fading conditions are always correlated in time. As a result, loss of numbers of consecutive data packets occurs bursty loss instead of single packet loss. Therefore, PSFQ uses the concept of loss aggregation, whereas low loss is detected. PSFQs combines loss such that the fetch operation deals with the window of lost packets instead of single packet loss. Sensor nodes usually has more than one neighbor in a dense network. PSFQ allows different segments of the loss window to be recovered from different neighbors. Shortcomings of PSFQs. Firstly, PSFQ does in sequence forwarding of data packets. For example, if any intermediate node running PSFQ as a transport layer protocol does not have data packet 2 and has all data packets from 3 to last data packet, then this node will not forward any of the data packet to the next sensor node. In the same manner, other nodes always remain idle until they get in sequence data packets. So this increases the time at which last data packet will reach to the target node. Secondly, there are some drawbacks in the pump and repair operation of PSFQ. Whenever in sequence data packets arrive, it waits for random time between Tmin and Tmax. For forwarding the data packets, nodes does this waiting by setting a schedule. Finally, in PSFQs, same thing as above happens. While repairing of the particular data packet will be failed if radio components does not reschedule the data packet to forward it ahead. Improved transport protocol. Out of order forwarding. As we have seen that in sequence forwarding result in an unnecessary delay, we are proposing out of order forwarding of data packets. We have implemented it as follows. Whenever data packets arrives at the sensor node, it checks whether it is duplicate or non-duplicate data packet. If it is a duplicate data packet, then it will be discarded. Otherwise, node will store the data packet into the data cache and schedules it to forward it ahead. You can see the comparison of average delivery ratio of PSFQs as a function of network size. Conclusion. We have initially presented various protocols available for transport layer in wireless sensor networks. After that, we have presented overview of PSFQ protocols. We provided some alterations to improve PSFQ's efficiency. We have also shown performance analysis of original PSFQ and improved PSFQ. It has been shown that improved protocol works better than original PSFQs in terms of error tolerance and average latency. We have evaluated both PSFQs and improved PSFQ using simulation. We have found that improved PSFQ has good tolerance and delivery latency.